So in this section, we're going to start by talking about relations. And a relation is a really simple definition. It's just a set of ordered pairs. Now, we talked about ordered pairs when we talked about graphing, things like that. So if we have a set of ordered pairs, it's a relation. I want to talk about two types of relations. One is a finite set of ordered pairs. So that means that you can count how many there are. Maybe you have 5 ordered pairs. Count the ordered pairs. Now, a lot of books don't make a distinction between the finite and the infinite, but I always like to point that out to students because we handle them a little bit differently. So a finite set of ordered pairs, we're going to see one in a minute. I could say I have 3 ordered pairs, or I have 10 ordered pairs, or something like that. I can count how many there are, and I might even be able to list them. An infinite set of ordered pairs, okay, that I can't list. There are more than I can count. Okay, it goes on and on. An example would be, so here's an example, y equals x plus 2. Okay, so if we say x and y are real numbers, well, how many real numbers can I have for x? There's an infinite number of real numbers, and I could always add 2 to a real number, and then I could get a y. All right, so the relationship would be the set of x, y, such that y equals x plus 2. That's one way to write the relation, but this is an infinite set. Okay, you can't list all the ordered pairs. What you can do is you can draw a picture of it, and this is a linear function, so the picture would look like some kind of line, not like that, but some kind of line that would represent an infinite number of ordered pairs. You can't, that line is made up of an infinite number, okay, of points. Okay, I just wanted to talk about that a little bit. So now we're going to go ahead and tell you what the domain is. The domain is the first component. It's called the abscissa, but nobody ever remembers that, so I won't worry about that, but that's what it's called. Or it's the x, the x's, right? Okay, so it doesn't have to be in terms of x and y, but on our Cartesian coordinate system, which is what we're going to use a lot of, they're going to do it in terms of x and y. So that's all the first elements, and that is a set. It's the set of the first components. Maybe more than one. So you could have let's have a little set of ordered pairs here, a little relation. 1, 0, oh, poo. Well, that's a really small set of ordered pairs. Let's have at least 2. So say you have a relation 1, 0, and 2, 1. Okay, that has 2 ordered pairs. It's a finite set. What would the domain be? And I usually go D for domain. The domain would be 1 and 2. Now notice the notation. I'm listing the set. I can tell you what the first components are. I only have 2 points in this relation right here. And that means it's finite. I just have 2. I can count how many points I have. And I have 2 first components, 1 and 2. Now, for this infinite relation, this line here, what would be the domain? Well, we talked about that. What could you put in for x? You can put in anything. So it's all real numbers. The way we show all real numbers is with interval notation from infinity to negative infinity. But this means all real numbers. Sometimes they'll list it like that, but if we're using the interval notation, it's convenient to do that. Okay, the range, well, you'll never guess, but the range is the second component. It's the set of second components. I want to say they use a different word other than component, but that's in the book. You can look it up. It's also called the ordinate, but nobody remembers that either. Ordinate. Okay. And it's the y's. Okay. All right. So in my relation here that I had, if I wanted to list the range, and I usually just put R for range, but you should probably spell it out. It'd be the set. I only have two second components, 0 and 1. So I just list them because I can. It's finite, so I can just list the range. Okay. For the infinite set, well, what could I get out for y? Well, I could actually get any real number because this line that I have drawn, it goes on and on and on, and so the domain would be all real numbers. Now, we're going to talk more and have more examples. This video is a little long, but anyway, I thought it would be good to give you all that right at the beginning. Okay, so here comes a fairly nice one. You don't have to have numbers for your ordered pairs. My examples did, but they don't have to be. So this is a set of ordered pairs. It says find the domain and range of the relation. So it's a set of ordered pairs, therefore it's a relation. Notice we have the squiggly brackets there. Okay. In the book, there's a chart, and I didn't clip that here, but it's got the last name of an actor or actress, and then it's how much money they make. In like, I don't know, thousands of dollars per episode. I don't remember the example, but they're relating a name and a number, right? Okay, so this is like Sofia Vergara. You know who I mean. Sofia Vergara. And how much money, I think it's how much money she makes per episode, like $43,000 or something. But you can look that up in the textbook. They have that. And then these other actors and actresses, I wasn't as familiar with them. I think they're all from the Big Bang Theory, but they're their last names and then how much they get per episode. Okay? All right. So we just have to find the domain. What's the domain? Well, it's all those names. It's Vergara, Parsons. Kind of a pain to write these out. That's why we like numbers. Galecki, Kuiko. I don't really know how to say these names. And Helper. That's the set. That's the domain. Those are the first components. See? Fun. This is, by the way, a finite set. The range, well, that's how much money they're making per episode. Now, you can put them in order from smallest to largest. Usually they do that. I don't really care. But see the 26? You don't list that twice. You only list it once. Okay, so 26, 27, 28, and 43. Okay, so that would be the answer. And we're just identifying domain and range.